Hello everyone, for First Updates Now, I'm Tyler Olds, and you're watching Behind the Bumpers, this fun show where we dive deeper into FRC robots and what makes them work. And today I'm here with team number 3452, GreengineerZ from Berrien Springs, Michigan. 3452 dates its rookie year back to 2011, where they won a Rookie All-Star Award, and has since won 6 events, including a championship division in 2017 and a state championship division in 2018, on top of also 4 other finalist awards. They also have an Engineering Inspiration Award to boot. They had an opportunity to compete last year at the FIM St. Joseph event, and we have an awesome 2021 robot here to show you today. Today I'm here with both Nick and Devin. And as mentioned, we're going to be breaking down this 2021 robot, maybe talking about some of the differences from their 2020 bot, and checking out some cool capabilities and functions, all here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. All right, starting on this robot, Devin, we're going to be talking about starting with the intake, which you have here on the table so we can really give a full breakdown of it. So tell me a bit more about your intake, what changed from the 2020 season, and what successes you've seen from it as well.
Yeah, so for the 2020 season, it was similar to something like we'd have in 2017 where you kind of drove over the ball and picked it up. We tried to veer away from that this year because we found it was very easy to run them over and get them jammed. So this year we have what would be 2 axles full of wheels. The first set of wheels would be a 3D printed, kind of like a 2-inch compliant wheel. We've got a couple right here. Each one, they're both of these are 3D printed. It just kind of forms onto the hub. There's no special pattern in to hold it on, but some of them are softer than others, and some of them are harder. These ones we have on here are the harder durometer per se. And then those would go into some Mechnum wheels to help center on the robot, also 3D printed. And then it's a run off a 775, and I think a 7-to-1 gear ratio.
So looking on your wheels, and you have a few things that are 3D printed on your robot, and we'll be focusing on some more of that later, specifically with your Swerve. How many different iterations did you actually come up with? I know you said you got a couple out there. Like, how many different ones do you have? And then the ones that you chose, are those the ones you always use, or do you ever swap them out for any reason?
So I think we have about 5 different iterations, mostly in changing the durometer. And then I think we're going to stick with these. We haven't really changed them out just yet, but these seem to be working good.
Yeah, it makes a lot of sense on there. So let's move in and actually check out on the robot itself. We're going to be going into the hopper a little bit and showing that off. And of course, we'll be going into the shooter as well too. But talk to me a little bit more about this type of hopper that you chose, how it's been working out for you, maybe what different iterations you went through on this robot, and anything in comparison to your 2020 robot as well.
Yeah, so for the hopper this year, it's just kind of it's got a single flat belt on top. And then it just kind of rolls the balls over it into the hopper. And what's interesting about the hopper is we have this kind of, with flat belts, they tend to want to find a high spot. So we 3D printed this thing to go on the hex shaft. It's got a high spot in the center. So it should just keep that flat belt nice and centered for us instead of running all over the axle like it would. And then one thing we did experiment with, again, is a 3D printed flat belt, which I have right here.
Oh, wow.
The only reason why it's not on there is it got a little bit loose in testing, and it got to the point where it was almost unusable, and we didn't want to do that for the at-home challenges, so we swapped it out for a Vex Pro flat belt.
What made you want to do a 3D printed one? I don't think I've ever seen that before, at least in an FRC robot. So what made you, is it just do it because we can sort of thing, or was there something in particular you wanted to try on it?
Well, there is partly do it because we can, and then another part is we usually do like the orange flat belt. This was the first year with the black flat belt, and if I can find it, yeah, here it is. We had some issues getting it to melt and mend properly. So I mean, this is held up. That once you get it in, it's usually there. But it's we wanted to see if we could get it better with a 3D printed flat belt. And for the most part, it worked. I'd probably just go a little bit smaller for the next one.
Yeah, fair enough. I'd love to see that whenever you do end up running that sometimes. Make sure you send a video out because I'm sure the FRC community would love to see that as well too. Do you know by chance how much like compression you put on the power cell when it's coming in through your hopper there?
In terms of right here or right here?
Either one. Or if you don't mind, if we can just put a power cell in, maybe take a look at that a little bit.
Yeah. So right here, what would be the intake? It would come in, ingest it, and help center it. And then this also right here, 3D printed, those help center it. So it would come in here, and we've got some pool noodles right here. If you want to just, there's like a half-cut pool noodle right there to help just kind of give the extra compression. And it would catch on this, and I think there's about 1/4 inch to 1 inch of compression in through here. And then that goes all the way back to what we call the power cell lift, which is again just another pinch point with a black Vex Pro flat belt that would push it up to the shooter. So coming back into the lift, it would pinch it right up here. So we have kind of just some circular tubing that would circular poly tubing that goes through, and it goes around the flat belt. And then what we did is this is being run off a single motor, and there's actually 2 axles that turn, this one and this one right here. And so what we do, we use chains so that we can come over here and then also back drive this one, so it would kind of spin the opposite direction to shoot it up into the shooter.
Let's go next into the shooter there, which I know Nick will be covering that. So talk to us a little bit more about this shooter, and then maybe talking about how it changed from your 2020 robot into this robot as well too.
So for our shooter this year, we went with a plexi backing and Coulson wheels for the main shooter, along with one of the new Falcons to run it. And we decided with a chain drive because it helps work as a slight flywheel due to the weight of chain compared to belting.
And looking on this as well too, so you have a fixed shooter, right, as it goes through. So from a tuning perspective, for the at-home challenges, there's still, a couple different places to potentially shoot from for that. How did you get the tuning down for that? Are you just adjusting the speed just pure that way, or is there any other sensors that help you out with that?
Speed. We went with speed and where we were sitting on the field to help dial in for our shots.
Yeah, can we see a couple power cells maybe coming in and shooting out of your robot? So Nick, wrapping up on this robot here, we're going to be talking a little about your Swerve, but not just your Swerve in particular. We're going to be covering more 3D printing that you've done on this robot with your Swerve. So talk to me a little bit more about what you've done for your Swerve drive in regards to 3D printing.
So this is actually the team's first year doing Swerve, and we opted to use the Thrifty Swerve modules with the Neos and the Neo 550s with the can coders, but we had multiple problems with the treads that came with. So we went through a couple of different iterations on attempting to 3D print a tread that goes onto the Thrifty Swerve wheels, and we ended up with something that works. We're still kind of testing it as it ran down on us quite quickly, but has worked so far.
So are those just different iterations that you have there, or is one of them a little bit worn down versus the other?
None of these ones are worn down because we haven't taken any of the ones that are used off of the robot yet, but this is our first iteration, which actually had smaller squares for the treading, whereas this is what we're currently using, which is bigger squares for the tread.
And what kind of difference does that make, or what have you seen from a difference from having the square sizes change?
It grips better.
But as of right now, you said you haven't taken the wheels off yet, so you're not quite sure in regards to what the wear is yet. Is that correct?
We've looked at the wear, and it's almost like going from driving on pavement to driving on dirt. They've smoothed out from squares to round something.
Yeah. That's really interesting. So have you noticed in that smoothing process, has how the robot drives, has that actually changed at all?
It didn't change at first, and then as we were practicing, it just kind of stopped. driving the
Oh.
same way and started drifting a lot.
Is that considered an advantage or not?
We're unsure about that at this time.
Yeah. I mean, these are more things I'd love to see, you know, as your team continues to iterate on this more and more, of actually seeing what these results are over, you know, 6 months time and even further. So, and I'm sure Ryan over at ThriftyBot would love to see those results as well too. So Greengineers, once again, thank you so much for taking the time to speak with us about your robot. Cool stuff going on. I love all the 3D printing. The new things that you're experimenting and trying, I think, are really cool. So can't wait to see, you know, if we ever get to see this robot compete in person, but once your at-home challenges videos get out, love to see more of that as well too. So thanks a lot for showing off your robot today.
Thank you for having us.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.